All right, we are on to the second half of this activity. We have 3 and 4, which are both from our notes from 8.8. So our first, number 3 problem is a rectangle lot is bordered on one side by a stream and on the other 3 sides by 600 meters of fencing. It says determine the dimensions of the lot if the area is a maximum. So this is part of that maximum minimum problems from our notes from 8.8. So we first can get a visual of our problem. We basically have this going on. We have our widths. We have one length, right? And then we have a stream that's covering one side. So we only need to worry about these parts, right? Because this is the fencing. Because we're not going to put fence near the stream, right? That's what they say in the problem. So from there, we want to first find the equations that we'll be using, right? So with fencing, again, that's over the borders. That would be perimeter, right? So a perimeter, if we remember those formulas, it's 2 times the length plus 2 times the width. However, with this one, we're actually going to do this way because remember we have 2 widths, right? But we only have 1 length. So our perimeter is actually L plus 2W. So from there we have that equation. Another equation we were wanting, right, because we're wanting to find area. That's something they say in the problem. Area, we know, is length times width. This one does not change for anything because no matter what, the area will always be this rectangle, right? Width times length, right? So, just like from our notes of 8.8, we find one of these problems that we can get one of their variables on their own. A simple one here is to get this L on their own, right? So from here, there's some adding and subtracting, which you'll see and get a hang of, but you should get to here where L is on their own, and we have the perimeter minus 2W. Now, we can plot in this 600 meters, because we know that's their perimeter. That's the amount of fencing that they have, right? Because that's what's it all going to cover. So this can actually become L equals 600 minus 2W. Now, we have a perfect plug-in, right? Because we have this L. That's where we will plug it into this wonderful equation for area, because we're wanting to find the maximum area, right? So from there, A equals 600 minus 2W times W. So that's where we see from here, we plugged it in, right? Now, our area, we're going to kind of distribute all that. We have a 600W minus 2W squared. That's by timesing W to both of these, right? It's simpler to see here, we're going to just switch these up. This still equals the same thing. These are the same thing. We just switched where our negative 2W squared, right? Where it's at. Now here is where we're trying to find the next step. We have a quadratic equation, right? Because we have a W squared. We're going to find the vertex. And how do we do that? We do that formula, right? We learned negative B over 2A. Now, our negative 2 is our A, right? And a 600W, sorry about that. Now that is our A and B. So we're plugging that in to here. I'm just going to do this on this side, right? We have a negative 600 over a 2 times negative 2. Now that gets us, you can put that in the calculator, you can do it by your head. That's actually going to give you 150. Now 150 is our W right now. That's what we're going to input. So the perfect way we can input this, what equation we can use, is this one, right? Perfectly we can find our length. So from there, We're going to do it over here just so we don't get confused. L is going to equal 600 minus, right, our 2, and our W, right, we found out right now is 150. So when you simplify this, you get length equals 300. So this is where you should see length equals 300, and our width equals 150. So that's where you'll plug it in here. So we have a 300 meters and we have a width of 150 meters. So that is where you get to there. If this is still not making sense, please let me know. I know it was a lot of information in class this week. So if you do need more videos, I'm going to send them along with this video I sent through the announcement. All right, so we're going to move to number 4. Number 4 is very similar to what we worked on for our activity. I'm just going to rewrite it down here so we can see what we have. All right, so for this problem at Sweet Harmony, I'm not going to try to pronounce this one, determines that when X 100 dulcimers are built, the average cost per dulcimer can be estimated by this equation. It says where CX is hundreds of dollars. What is the minimum average cost per dulcimer, and how many dulcimers should be built to achieve that minimum? So we're trying to find a minimum now instead of a maximum like number 3. But we're still using the same formulas, right? We're going to try to find that vertex. And we found that, right, through that negative b over 2a. Now, what is our b? What's our a and our b, right? Remember, our a is going to be that 0.1, and our b is going to be that negative 0.7, and c, which is not really applied here, but that's what we have, right? So from here, we find our vertex, our x input, right? We have a negative of negative 0.7 over 2 times 0.1. So from that, we can write that a little simpler here. If that's a positive 0.7 now, right? Over a 0.2. Now that you can put in your calculator, do by head, whatever makes sense to you. That gets you a 3.5. Now that is our x input. So from there, we are going to input our 3.5. This is going to find our cost, right? This is the number of dulcimers they're going to order, right? So we can put that right here. Well, actually 3.5, it turns into 350. In the problem, it says whatever it is, it's actually times 100. So it's 350 dulcimers. But when we're plugging this in, we have 0.1, 3.5 squared, minus 0.7 times 3.5, right? Plus 2.425. And you can just trust me on this. You can put in your calculator, whatever you got to do. You will get to the answer of 1.2. Now that is the cost, right? But we can't put 1.2, right? Because it's actually times 100. Because, again, from here it says the cost is actually in hundreds of dollars. So 1.200 actually is 120. So that is how we get to those solutions there. Again, it is very similar to number 3. I would highly recommend going over 8.8 as much as you can. Again, I'm going to send you all some videos that can help see different ways to do these problems, and also some more practice problems. Alright, hopefully this video was helpful, and I hope you guys all have a good weekend.